Hello. Welcome to our partner session, Mod 3D Assets for Virtual Worlds, tuned with Intel GPA. I am Pamela Harrison from Intel. I'm a software technical consulting engineer for Intel Graphics Performance Analyzers. I help game developers use Intel GPA to find bottlenecks in their games. I'm here today with Alex and Tim. Alex Porter, CEO, and Tim Porter, CTO of ModTech Labs, are going to show us how they use Intel GPA to optimize their applications. First, a little introduction. Alex and Tim are longtime entrepreneurs passionate about using technology to enhance human imagination. They are Intel top innovators since 2017 and are active mentors and technologists that contribute to making standards and educational materials for students, developers, and even lawmakers. Recognition for their work includes a CES 2022 Innovation Award, being named to the Forbes Next 1000, and chosen as a Rising Star Award recipient. Very impressive. So Alex and Tim, I said that you're Intel top innovators. That's how I met you. I met you through that program. But tell me what that means. What does that mean for you? What does that mean for Intel?
Hi, Pamela. Thanks for having us. We're excited to be here today to share more about our journey, including working with Intel for the last 5 years. So we've been top innovators, and what that means is that we get to contribute to the Intel ecosystem by way of educating folks, getting early access to hardware and software packages that Intel is giving to us pre-release. And that allows us to prepare ourselves and our clientele for the next generation of software and hardware innovations coming from Intel.
We work in a number of different verticals and different areas, and we're going to talk about today our work in everything from iDrive VR to our 3D scanning and processing capabilities.
Nice. So your passions run a gamut of various things. So tell us a little bit more about your work.
Absolutely. So I am the CEO of ModTech Labs, and ModTech Labs is an automated processing solution that intakes photos and videos and uses AI to create dynamic 3D content for playback on any device. And so we're seeing a lot of use cases in the e-commerce space and gaming, as well as immersive media, including augmented reality and virtual reality. And we have worked in the immersive media space for over 7 years now. My background is in interior design and construction technology, so the visualization of places and spaces. And we're able to bring that into the company that we're working on now and really working to make it more accessible for folks to create this really amazing new content.
My background, on the other hand, I came from games and movies. And video games, I was a technical artist, and movies, I was a pipeline technical director. Last movie I worked on was Alice in Wonderland Through the Looking Glass at Sony Picture Imageworks. And my entire mission while working at studios was to make artists, developers, designers not only more efficient, but enjoy their work more. Most of the job and most of the things that you do at any given studio can be quite boring because it's repetitive and isn't really part of the job itself, but part of getting to the job itself. And so I automated a lot of those things using tools, and that's what Mod is built off of, is being able to go ahead and create these ecosystems and these automation plays that make it to where people can enjoy making 3D again.
Oh, that's cool. So you guys are great team members. Different skills go well together. So getting into GPA then, how do you use it? Why did you start using it?
So the GPA system takes assets and optimizes them for playback on many types of devices. This is really important in applications, especially that are throttled by compute. So think about a virtual reality headset, for instance. And in this case, we actually have been using GPA to optimize our assets for playback across many devices for the last few years. I'll let Timmy tell you more about the details.
Sure. So we ended up working with a company called Stealth on a product called iDrive VR, which helped train people into using power chairs. We're talking about electric wheelchairs. The biggest problem that happens in that world is that training is very difficult. If you get into a power chair, then you end up having to drive around in a physical environment. You can flip it, you can hurt yourself, you can hurt other people. And so creating a safe place and location is very important. But in that, so is realism. To immerse people effectively into a VR environment or any digital environment, you want it to be as realistic as possible. So that's where being able to take the original CAD models that created these chairs was really important. So we used Intel's GPA to create a system that understood not only where people were looking, but understood the assets themselves so that we could go ahead and optimize those effectively. I'm going to play a video of what iDrive VR looks like and some of the assets as we went through and how we utilize this system to go ahead and optimize. So this is a video of iDrive. Through. As you can see, it's a typical environment. They start out people in school gymnasiums so that they can learn how to go ahead and drive in a fairly safe environment. And this is the original model. The one on the right is about 8 million tries, while the asset on the left is about 67,000 triangles. So we were able to utilize GPA to take these assets into the VR environment and have an automated system play through over and over and over again while getting that training data back to understand at what level we could optimize these assets to. And so it ends up becoming a touchless system that really allows for us to not have to worry about the assets as they go in and out.
One of the great things about using GPA as well is that as an executive and a secondary technologist, I myself do not code or work on those systems. However, there's a beautiful pain into actually seeing the process, seeing the spikes and the spurs and where things can be improved and what the holdups are that I can look at and I can be explained, what the opportunity is to really improve the game overall.
That's super cool. So even as a non-technologist, you can use GPA and see things that are happening and point things out to Tim that don't look like they're being efficient.
Absolutely.
So what kinds of issues did you find with GPA?
So the biggest thing, and this is something going back to understanding what you find with GPA, I think goes back to more of a mentality of how optimization works in general. A lot of companies and a lot of people go, we need to have the frame rate at 60. It has to be solid all the way across, or 90 or whatever they're in. And the biggest problem with optimization in that methodology is that you don't actually optimize for these things like low-hanging fruit or things that really matter. Having a pop-up or a UI that shows up on screen that's a low frame rate may not affect the experience. And so that becomes a really kind of dangerous mentality of, well, we need to optimize everything. You end up wasting resources in the wrong place. GPA can allow you to do really amazing things. This is kind of an advancement of what I did when I was at major studios. So when I worked at Gameloft, I would go ahead and create a locking system that went onto every one of the phones that we handed to people. So each one of our QA would have this logging system on the phone, and it would go ahead and play through and capture what frame rate was, kind of what was happening, a little bit of the system that was going along. And then I would ask the QA team, whenever they got done with their QA testing, if they ever felt at any point in the time the game didn't feel well. Was it slow? Was it chuggy? Or did the frame rate just not feel nice? And then I would go back to the logs and I would feed it backwards. I can do that same thing with GPA, where I don't even have to build a system. I don't have to understand. I can literally go through and I can watch playback videos. I can sit down with the QA team. I can do that same thing, but I have so much more information. I can get the frames before, after. I can see, and this has happened a number of different times, where you think that the thing that is the issue isn't really the issue. It's the thing that's all the way in the back. Say, for example, you don't have your culling on. So what culling does is it tells the asset behind the asset that you're looking at to turn off. Sometimes that doesn't work the way that you're expecting it will, and ends up rendering the asset that's in the back. And so you think, well, obviously the way the system's supposed to work is those assets in the back are supposed to be off, but the assets in the front are supposed to be on, but that's not happening. GPA will capture that. You can see it in heat maps. You can see it in a very colorful manner. It's even gotten to the point where I hand it to the QA team so that they can go ahead and test and play with the assets and go, oh, I saw this, I saw this. And it ends up bringing that bar down where you end up going back to the holistic approach of optimization, what it's really intended to do, which is make a good playing, entertaining playing experience. So
Wonderful. So GPA is very helpful, and you can use it across the team, it sounds like. And even if the other people don't use it, they can tell you where they find an issue, and you can look at that spot and gather the detailed data and move on from there. That's fantastic. That application, the wheelchair training, that's already out in the world. Insurance companies are more willing to pay for wheelchairs if their clients actually take the test, I've heard. And so that's wonderful. So you're working on other things now. So how are you using it now? What's going on with it?
Yeah, absolutely. So we've actually taken a lot of this data that we accrued from the iDrive experience of understanding head look, understanding where folks are focusing, and we fed that data into a machine learning algorithm to help us actually launch a beta app that is called Mod 3D Scanner. This is an app that uses guided photogrammetry, so it's an augmented reality overlay. And the user actually guides the phone around this augmented dome and matches the bubbles over top of an object, and it allows almost anyone to capture objects, real-world objects, to make them 3D. We use a lot of this data to really create this optimization technique and approach the process for lower-end mobile phones. So using phones from Galaxy 6S and up, customers can actually access these tools, which wouldn't have been possible if we had not had the data and the opportunity to see it through GPA.
The best thing on the flip side is we're actually able to take that data and that information, and we can feed it into our algorithms for capture side. So once we have the capture done and people have done all of their photos and then they end up sending it up to our servers, because we know not only where those cameras are in three-dimensional space, we understand what the individual is looking at and what their intent was based off of this training data. We feed that back into the system so that it helps create the assets. So I'm going to play a quick video that you can see of Alex going through and doing some of the photos, and then we'll show what some of the optimization is. So it's just as easy as this. You have your phone out, it ends up showing you in augmented reality where the scanning is. And here's two different assets that we have. The asset on the left and right look almost exactly the same. One of them is less than 5% the original footprint. So the one on the asset on the left is under 10,000 polygons, while the one on the right is about 280,000 polygons. And the texture on the left is a 2K texture, while the texture on the right is a 4K texture. So we're going to zoom in here on the very optimized one and then scroll around to the back, and you can see just how well the optimization system works, the mesh generation system works, and this is all because of our understanding of what people are looking at and what people are doing through the automated system that we built that involved GPA.
So this is indicative of some of the use cases that we're seeing our customers use with their 3D assets. So this particular asset is a fossil. It's fossils set in rock, and it's carved out. This actually is a home decor item that we have. It lives in our living room. What this could be used for is a prop in a video game. This could also be turned into an NFT and actually a digital asset that can now be bought and sold as a digital good. It could be used inside of a Fortnite for an avatar accessory. There's a wide variety of opportunities for monetization on the digital goods side that are really opening up now, and it's super fantastic time to be in this world.
As we all know, we've been talking about, and this has been what's swirling around, the metaverse. And this is one of those first stage and those first steps towards that. The only way that you end up creating a fully immersive digital environment that includes everything from the real world is bringing in real world objects to the digital world. And the only way that we can do that is through 3D scanning. Some of the really amazing advancements that we're working on right now with our technology is to reduce the number of photos and being able to scan objects that would have traditionally not been able to do. And the only way that we were able to do that is by understanding the way that people look, the way that people think, and where they're putting their attention when they actually are observing an object. And that only really was capable through the automated system that we built through GPA.
Yeah, dropping the technical skills and allowing, your everyday person, hopefully in the very near future, to also contribute to this digital, goods arena is the only way that we are going to be able to do this at scale and really create the metaverse in within our lifetimes. And ultimately, GPA enables us to create tools that anyone can use.
That's amazing. So let me put this all in context, is that you use it, so you haven't developed a game as far as I know, but the training program for wheelchairs is like a game. They're going through a simulation and reacting to it. That's like a game. And then creating the avatars, that's completely different. But you can use GPA for both. Any live rendering that needs to happen, you can use GPA, and it will show you, where you're GPU bound or CPU bound, and dig down into the details of the frame so you can see, oh shoot, I'm drawing outside the view, or lots of other things. So that's amazing. Are there any other details you want to add?
I think the biggest thing to remember is that a lot of people are afraid when it comes to using profilers. Most profilers are built for developers. They're built for people like me, and they're definitely built for people who have a very deep understanding of what's going on. And what's cool about GPA is that you can't do that. I can dig absolutely down to the most bare metal. I can see every single call that goes through. I know which shader has the highest ALU. I know every little bit of detail that I need to. But it's also accessible from a 50,000 foot view. And that's really important when you're trying to deal with optimization. 95% of the time, I am not digging down to the bottom of things, and neither are anybody else on my team. There's no reason for them to do that, because most optimizations and most things, when done with a very slick, smart tool that understands the way that people want to use a tool or need to use an optimization tool is built, is that you need this kind of macro view. You can quickly get in, you can get out, and then you can get back to work. And that's really what developers want to do. We don't want to sit there and I have to learn everything about a tool. I don't want to dig down deep and do all of these things. I want to be able to find the answer that I want to need and want or need, and then I go ahead and I jump through GPA very quickly. Boom, I'm in and out in usually about 2 to 3 minutes. So that's the best thing.
Yeah, and let me add that GPA doesn't need any instrumentation. You don't have to do anything. You just install GPA and run any executable through it. And as long as we support the API, DirectX 11, DirectX 12, Vulkan, and then we're adding a little more OpenGL and OpenCL, then you can use GPA easily without having to change any code. And in GPA, you can do experiments to check out, well, if I made the pixel shader simpler, how would that change my performance? And so free tool, easy to use, and so I'm really happy that you found it useful. Thank you, Alex and Tim Porter of ModTech Labs. Find more information about what they're working on their site. And be sure to tune in to more of our Game Dev Stories series.